Doctors,
Yes.
I have problem of my microphone. I have a question. How many question will come about problem to solve? Like, I mean, not a theory.
My
Another.
dear, out of eight questions, 2 questions are theory. Remaining 6 questions are problems. Okay, numerical type.
Okay. Thank you, Doctor.
Okay, my dear. Okay, brother. My dear, it's my kind advice. Please don't send the message by your group members. If you have any questions, open your mic and raise the question to me. Because every time I am just hearing the sound of sending the message. It's my kind advice. Please try to avoid that. Understand?
What again, Doctor?
If you want to ask me a question, open your mic and raise the question to me. Because some students, you type the messages and you are chatting among yourself. So please try to avoid that.
Okay, Epson.
Okay. So today we are going to discuss some important information about thermodynamics. That means we are going to study the concept of temperature, what is heat, how many laws we have in thermodynamics. So we are going to study some information from thermodynamics macroscopically. What is meant by macroscopically? We are going to study everything outline oriented. We are not going deeply, just outline. We are going to study general information about what is heat, what is temperature, what are the laws of thermodynamics, how many types of modes we have the heat transfer. So these are all the things we are going to study from this chapter. So my dear, please listen carefully. So what are the topics today we are going to discuss? We are going to discuss some basic information, that means the basic introduction about heat and temperature, because both are not exactly the same, both have the different definition. The second one, we are going to study the conversion of the temperature to different scales. So we have 3 different scales: Celsius, Fahrenheit and Kelvin. So we have some specified formula for the conversion. And then we are going to study the laws of thermodynamics. There are 4 laws. What are the 4 laws? First, 0th law of thermodynamics, first law of thermodynamics, second law of thermodynamics and third law of thermodynamics. So overall there are 4 laws. And then we are going to study the concept of thermal expansion. When the temperature increase, what will happen? So if you have any materials, when you subject that material under some change in temperature, what will happen? That material will undergo some expansion. So here we have 3 expansion. One is linear expansion, and the second one is area wise expansion, and then third one is volume wise expansion. So these 3 expansion we are going to study from this topic. Clear? So linear, area and volume. And then we are going to study the concept of what is specific heat capacity. So we have some formulas in this topic, and that formula is very easy. And then this topic is very, very important. And here we are going to study the concept of work done by the gas molecules. So we are going to explain this concept of work done by using the PV graph. What is PV? P stands for pressure, and then V stands for volume. So pressure, volume, graph analysis. And then we are going to study the different types of heat transfer. So through these 3 types of transfer method, we can transfer the heat from one region to another region. And then finally, we are going to conclude these classes by studying some special cases. We are going to use all these special cases in chapter number 19. So all these special cases we are going to implement it in the next chapter, that is chapter number 19, and chapter number 19 is also related with the thermodynamics. Now we just come from the first slide. So from the first 2 slides, these 2 points are very, very important. So whenever you are going to study the concept of thermodynamics, these 2 are very, very important. What are these 2, my dear? System and environment. So what is meant by system? What subject you are going to analyze. For example, if you take any object is nothing but our subject. So if you take any object, when you are about to analyze that object is called as system. And what is environment? environment is nothing but what are the things which is surrounded by this system, surrounding to this system. So if you take a cup of tea, for example, if you take a cup of hot tea, what are the things that surround this cup of tea? So we are going to analyze these two systems whenever you just go for studying the concept of thermodynamics. So this system and environment plays an important role in thermodynamics. Now, what we are going to do, we are going to study the comparison between what is heat, what is temperature. That is nothing but the general introduction about heat and temperature. I told you, my friend, actually some people, some students or some people, what they are thinking, they thought this heat and temperature are exactly the same. But in general, according to the physics concept, it is not exactly the same. Both have some different terminology. That means both have some different definition. What is the definition for heat? Heat is a energy. That means if you just take some, if you are just taking some, for example, you are going to heat some material. What will happen? For example, you take a rod, put one end of the metal rod in the fire, and please hold the other end of the rod in your hand. What will happen? What will happen?
It's come high.
My dear, you take a metal rod, put one end of the rod in, my dear, you take a long metal rod, you put one end of the rod in the fire, and you are going to hold the other end by using your hand. What you will experience after some time?
The heat will transfer from the rod.
The heat will be transferred from one region to another region. What is the first region? Always the heat will be transferred from hot place, that means hot region, to the cold region. That is the definition for the heat. When you come for studying the concept of temperature, temperature is the measurement of, that means measure of hotness and the coldness. Suppose if you take any object, suppose if you take any system, if you want to measure the hotness and the coldness of the system, then we have to say we are going to study the concept of analysis. That means the temperature concept. So whenever you are going to measure the hotness and the coldness of the object, so that will come under the category of the temperature. So here we are going to express this temperature in three different scales: Celsius scale, Fahrenheit scale, and Kelvin scale. Generally in physics, each and every term we have to represent it with some symbol. So in heat, for example, if you want to represent this heat, all the times you have to represent the heat with a letter caps Q. Likewise, temperature, all the times we have to represent with the caps T. So the unit for this energy, heat energy, is joules, and the unit for this temperature, because we have three different scales: Kelvin scale, Celsius scale, and Fahrenheit scale. But the SI unit for the heat is joule, but the SI unit for the temperature is Kelvin. Understand? These are all the four difference between heat as well as the temperature. So generally in theory question, we will ask some points. You have to write some difference between heat and temperature. So you must know these 4 points when you come for the exam. Understand?
Doctor?
Yes.
Yes.
Here, if it is temperature Celsius, the unit SA will be Kelvin.
My dear, if you want to use the temperature in terms of, because this is a SI unit, so if you just give any unit, if you want to convert that unit in terms of SI unit, suppose you have the degree Celsius. So if you want to give the answer, you have to you have to convert the degree Celsius in terms of Kelvin. Understand?
Yes, I got it.
So now we are going to study how to convert the scale from one temperature scale to another temperature scale, because we studied three different scales we have. The first one is degree Celsius, degree Fahrenheit, and Kelvin. So now we have some specified formula to convert from Celsius to Kelvin, because everybody we knows this formula. If you want to convert the Celsius from Kelvin, you have to add that value with 273. For example, I have 20 degrees Celsius. If you want to convert this 20 degrees Celsius to Kelvin, what you have to do? You have to add 273 with this value. When you just add this 273, what you will get? You will get 293. So that means this 20 degree is exactly equivalent to 293 Kelvin. So what we did? We just add 273 with this number, when you just add with this number, you will get the answer in terms of Kelvin. So that is this formula. So you can either use this formula for convert from Celsius to Kelvin or Celsius to Kelvin or Kelvin to Celsius. Understand? Likewise, if you want to convert the temperature from Celsius to Fahrenheit or Fahrenheit to Celsius, you have to use this formula. This is the general formula for converting the temperature from Celsius to Fahrenheit and Fahrenheit to Celsius. So if you have any values in terms of Celsius, substitute the value here, rearrange this equation. When you rearrange this equation, you will get the answer in terms of Fahrenheit. So likewise, you have to work out with the formula. So these two formula is our first formula from this chapter. So these two formulas are very, very important, and we have some questions in the numerical part, how to convert the scales from one temperature to another temperature. Understand? Clear?
Yes.
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 Okay, now I have one question, my dear. Actually, that information is not given. I don't know whether it is given in your book or not, but my question, whether degree Celsius is equal to Celsius degree or not. Is both are same or different?
Different, Doctor.
Different.
So what is the difference between this and that?
When I write C, that's mean 1 Celsius.
Degree.
My dear,
This degree
what is the
and this
difference
not.
between degree Celsius and Celsius degree? So now my question, whether the Celsius degree Celsius is equal to Celsius degree or not. So Mr. Abdullah, he told it is not equal. Answer is correct. But what is the reason?
The degree is
Transfer.
Because one of them is like a percentage, doctor, right?
What?
Doctor,
One of them is like a percentage.
No, it's not a matter of percentage, my dear.
Doctor.
Actually, it has some meaning. Can you please? So, okay, please listen here. I will tell you what is the difference. My dear, suppose if you want to mention the temperature of some particular body, for example, I am asking you the question, what is the temperature of this room? So, what should be your answer? The temperature
25.
of this room is 25 degrees Celsius. So, whenever you are representing the temperature of some individual body, you have to use degree Celsius. Clear? Understand?
Understood.
Can you repeat, Doctor?
When you have to use the Celsius degree, when you are going to find the difference between two temperature, for example, I have 0 degrees Celsius and 100 degrees Celsius. Now, what is the difference between these two?
100.
Okay, better I can just say,
100.
I have 10 degrees Celsius, I have 100 degrees Celsius. What is the
90.
difference between these two?
90.
When you are about to
90.
find the difference between any two temperature, then you have to use Celsius degree.
Also
Clear?
with the convert, Doctor.
What?
Also with the convert, when I convert to Kelvin.
Because once you find, you can just use for the conversion by using the formula. That's a different thing. But the concept for the degree Celsius with the Celsius degree is different. Understand?
Yeah, I mean, when I added the Kelvin to find the Kelvin,
My dear,
it will be
okay.
Celsius degree.
Yeah, I understood your question. You are asking whether the Celsius degree, when I was about to convert to Kelvin, whether I have to do something or not. Am I right?
Yeah.
Okay, now my question. Just give me the answer. My dear, I have 10 degrees Celsius. Okay.
Okay.
And then I have 100 degrees Celsius.
Oh, yes.
Listen,
I
my
got
dear,
that.
listen carefully. I have 10 degree and Celsius and the 100 degree. Now, could you please tell me what is the difference between these two?
90.
90 Celsius degree. Am I right?
Yes, you are right.
Okay. Can you please convert this 10 degree to Kelvin? So what you will do? You have to add 273. Am I right?
Yes.
Yes, you are right.
Okay. If you add 273, what you will get?
288.
283 Kelvin.
283. Am I right?
Yes, you are right.
283 Kelvin. And here, when you just add 273,
300.
373.
how much?
373.
373. 73 Kelvin. Now, can you please take what is the difference between these two?
90.
90
Am I right?
Kelvin. Yeah.
Yes.
Yes, you're right.
So your Kelvin is exactly equal to
Plus degree.
Celsius degree.
Kelvin is equal to Celsius degree, but your Kelvin is not equal to degree Celsius. Keep this information in your mind. Understand?
Understand.
Yes.
Clear? My dear, this is the very basic information. Before you studied this thermodynamics, you must know what is the difference, because most of the students, most of the people, what they are thinking, this degree Celsius is always equal to Celsius degree. It has different meaning. So keep, as a student, you must know these things. Okay?
Okay.
Okay, that's good. Okay, now let's we come for this slide. What is given in this slide? I show the thermometer with different scales. Am I right? Fahrenheit scale, Celsius scale, and Kelvin scale. Let's we consider the Celsius scale, because everybody, we are using always the Celsius scale. Am I right?
Yes, you're right.
Yes.
Doctor,
Okay, so
here also the Fahrenheit, it's different. Fahrenheit degree different and degree Fahrenheit.
actually this is applicable only for here, my dear.
Only Celsius.
Only for Celsius. Clear? Okay. Now you can see here I mentioned 3 different scales: 0 degree Celsius, 100 degree Celsius, and minus 273 degrees Celsius. Am I right? Okay. Now I want to convert this 0 degree Celsius to Kelvin. So what you have to do?
Add 237.
You have to add 273 Kelvin. 273. When you just add 273, you can easily convert this 0 degree Celsius to 273. Suppose if you want to convert this 0 degree Celsius to Fahrenheit, what you have to do? You have to use this formula to convert from Celsius to Fahrenheit. So when you are using this formula, what you will get? You will get this formula. Am I right?
Yes.
Yes, you're right.
So likewise, if you convert this 100 degrees Celsius to Kelvin, you will get you have to add 273 here. When you add 273, you will get 373. When you are using that formula, you can easily convert the Celsius to Fahrenheit. But the most important region is this region. So what is given here? My minus 273 degrees Celsius is exactly equal to 0 Kelvin. Am I right?
Yes, you're right.
So this 0 Kelvin is called as absolute zero. So my dear, you will get some 1 mark question, theory question. What is absolute zero? So you have to give the answer. Absolute zero is a temperature. Either you have to write the value in terms of Kelvin or Celsius. So what you have to do? Absolute zero is 0 Kelvin or minus 273 Kelvin degrees Celsius. Now my question, is it possible to reach this absolute zero in our day-to-day life? Is it possible to reach this temperature?
Yes, I think.
No.
No, doctor.
No.
Who says yes, my dear?
Me, Mr.
So it is not possible. So in our day-to-day life, in this year, it is not possible to reach this minus 273 degrees Celsius. So we have 4 losses. Am I right? What are the 4 laws we have? 0th law, first law, second law, and then third law. Am I right?
Yes.
My dear, I am extremely sorry for this line because I was irritated. But this pen is working very good in my laptop. But it makes some problem in my desktop. So second law and third law. Clear? Okay. Now, what is our third law? Our third law says, what is written here?
We can never reach absolute zero.
It is impossible to reach this absolute zero temperature. So that is nothing but your third law of thermodynamics. So out of these 4 laws, we got the information for the third law of thermodynamics. Am I right? So what is third law says? It says we never reach absolute zero. Why? Because at absolute zero, all the vibration gets stops. My dear, our earth is running because of these atoms. Am I right? Am I right or not?
Yes.
Yes, doctor.
Each and every particle is made up of an atom, and all these atoms get vibrated. If there is vibration, then life will be exist. If the vibration stops, there will be no life exist in this world. So at 0 Kelvin, is there any vibration? You can see this is vibration. So here what happens, my dear? Is there any
only
vibration here at 0 Kelvin?
Vibrating.
So that means
No
if
motion.
the vibration is not there, there will be no motion. If there is no motion, no life can exist in this absolute zero. That's what the third law of thermodynamics says. We never reach absolute zero. So whenever you increase the temperature, what will happen? The atom's vibration gets more, because we studied these things, am I right? Whenever the temperature increases, the atomic vibrations will be more. But when you just go for absolute zero temperature, there will be no vibration. If there will be no vibration, no life can exist in this world. So we never reach this absolute zero. What is absolute zero? Absolute zero is either 0 Kelvin or minus 273 degrees Celsius. Understand?
yes.
Yes, please.
Okay.
Understand.
Now we come for the 0th law of thermodynamics. What is it says? You can just see the picture. My dear, I have a box. You can consider this is a room. It's up to you if you consider a box or room, whatever it may be. So I just divide this box into two compartments. This is my compartment 1. This is my compartment 2. I set some temperature in compartment 1. I am setting the same temperature in the compartment 2. So what will happen, my dear? Here also the same temperature. Here also the same temperature. Am I right?
Yup.
Yes, sir.
So you can see the first picture. I have a box which has two compartments, compartment 1 and compartment 2. I set some temperature in compartment 1. I set the same temperature in compartment 2. Now, what will be the temperature of this room? Or what will be the temperature of this entire box?
Equal.
Equal. So, whenever you have the thermal equilibrium, then you have to say 0th law of thermodynamics. Clear?
Can you repeat the last part?
Clear? What?
Can you repeat the last part?
My dear, if you have a for example, you consider, I'm just explaining this 0th law of thermodynamics from this picture. I have a box with two compartments. Okay. So here I set a 24 degrees Celsius, for example. Okay. Clear?
Yes.
I set the same temperature compartment B also. Now what will be the temperature in compartment A and B?
Oh, equal, the same.
Equal. Now, after I set this 24 in compartment A and B, then I am going to remove this block. So when I just remove this block, what is the temperature of this entire blocks?
The
Will be the
same.
same.
No.
So we are maintaining the thermal equilibrium. Am I right?
Yes.
Okay.
So whenever you are just studying the concept of thermal equilibrium, then 0th law of thermodynamics speaks there. Understand?
Victor,
Yeah.
I have a question.
Yes.
If I put a metal inside the liquid and the liquid and metal has the same temperature, can we call that the 0th law of thermodynamics?
Yes. If both body maintain the same temperature, then you can say.
Oh, okay. Thank you.
Clear? Because what is written here? When it experience no net change in thermal energy. If there is no change in the net thermal energy, then you have to say that a body is under thermal equilibrium. Am I right?
Yes.
Yes.
Am I right or not?
Yes.
sir, right.
Yes, you are right.
Research.
So this is nothing but zero. So if you take any two object or any two bodies, when you just subject that body in the same temperature, both body will remain the same temperature. By that, thermal equilibrium will be happen on this body. So what you will get, there will be no net change in the thermal energy, because both body have the same temperature. When the body gets same temperature, there will be no change in thermal energy, because both will get the same value. Am I right? So in such a case, we have to say this is nothing but 0th law of thermodynamics. Understand?
Okay, understood. Doctors, A and B,
Yeah.
it mean system or environment here?
My dear, this is system. All
System.
these are environment. All
Okay.
these, whatever the things you have surrounded by this A is environment.
Okay, thermal equilibrium. It mean two system inside join together.
My dear, whenever you study the concept of thermodynamics, you have to consider both the object as well as the environment. So whatever the things are surrounding this object, it will be nothing but the environment. So the environment also has the same temperature right now according to this diagram. Am I right?
Yes, you are right.
Clear?
Okay.
So my dear,
Clear.
how many laws we studied? We studied already third
Two.
law. Am I right? What is third law?
Two laws.
We
I
never.
mean, this is the third law.
We never reach absolute zero. What is zeroth law? Zeroth law tells you something about the thermal equilibrium. Am I right?
Yes, yes.
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 Okay.
Yes.
Now let's we come for the second law. What is second law? Have you ever hear about this formula, second law? I take a metal rod. My dear, listen carefully. I take a metal rod. I just fire. That means I'm going to heat one end of the rod with a fire. I'm going to hold the other end of the rod by using my hand. What will happen after some time?
Heat transfer.
The heat will be transferred from hot region to the cold region. It will be transferred like this. Am I right?
Yes.
Yes,
You
yes,
are right.
right.
So whenever the heat will be transferred from hot region to the cold region, that is nothing but your
Second law.
second law. So this is the definition for the second law. The heat always transferred from hot region to the cold region. Clear?
Doctor, can
Yes.
you repeat
Yeah.
point? Dr.
What?
Mustafa,
Yes.
can you repeat this point?
You have the metal rod. Okay. Understand?
Yes.
You just heating one end of the rod. That means you consider this is my region A, this is my region B. Okay.
Okay.
I heated the region B with fire. So what will happen? So you are holding the region by using your hand. So you are just using your hand in this region. So after some time, what will happen?
The
My
higher
dear,
one
I am
comes.
asking you the question to you only. Just give your response. So after sometimes what will happen? Heat will be transferred from region B to A. Am I right?
A.
So whenever the heat is transferred from the hot region, this is my hot region. Am I right? And this is my cold region. So whenever the heat move from hot region to the cold region, then second law speaks. So the definition for the second law is heat always transfer from hot region to the cold region. Clear?
Yes.
Like
Clear?
cigarette,
So what?
like cigarette.
My dear, could you please give me some other different example? Yes, of course. Cigarette is also one of the things. When you are using this, because I don't have this type of practice.
No, it is
If you feel okay, you can just take it. I have no issue. But I have no experience about this cigarette.
I have more experience, Mr.
Okay, so forget about that. But we have to use very good example, my dear. Understand? Don't go for the negative examples. Always just go for the positive examples. Huh?
Yep.
Clear? Okay. What is
Yes.
remaining now? What is remaining now?
The first law.
So the first law of thermodynamics, one of the important formula, my dear, in chapter number 19, we are going to use this first law of thermodynamics for solving many questions. So please, my dear, first law of thermodynamics have some specified equation. With the help of the equation only, you can solve some important question. So you should memorize that equation. That's very, very important. We are going to study this first law of thermodynamics after a few slides back. Okay, so when we are just crossing few more slides, you will get the information about what is first law of thermodynamics. Understand?
Understand.
Clear?
Clear.
Okay. Now,
Yes.
now we are going to study the concept of thermal expansion. I told you already, my dear, the thermal expansion has three types of expansion: linear expansion, area expansion, and volume expansion. So if you want to study the concept of area expansion and volume expansion, you have to get more information about this linear expansion, because you have to use this expression for getting this, because we have the expression for the linear expansion is this. Am I right? Am I right or not?
Yes,
you're
Doctor.
So
Yes.
if you want to get the answer for this area expansion and the volume expansion, you have to use this linear expansion equation. My dear, linear expansion means only one direction the expansion takes place. Area expansion means two directions, so two sides. For example, if you take an example of the metallic rod or whatever the material, you take one rod, the lengthwise rod. When you heat one end of the rod, what will happen? The rod will expand a little bit. Am I right?
Yes, you're right.
So whenever the object gets small expansion in terms of lengthwise, we have to say it's a linear expansion. So linear expansion, only one side the expansion takes place. What is your area expansion? Area, what is the unit for area expansion, my dear? What is the unit for area expansion?
Delta 8,
Meter cube.
delta L.
Huh?
Meter square.
Meter square.
Meter square. So meter square means length multiplied by length gives you area. Am I right?
Yes, you're right.
Yes.
So what is volume? What is volume? Length multiplied by
Meter
length
cube.
multiplied by length. What's the unit?
Amps cube.
Meter cube.
So if you want to get the answer of this area and volume, you must need the information about the linear expansion. Am I right?
Yes,
Yes.
you're right.
So if you want to get this relation, just have a look of this picture. Initially, my rod has the length L0. After I heat this, the temperature is changing from T0 to T. Am I right? So initially the temperature of the rod is T0. After I heat this rod, the temperature of the rod becomes T, and also its length get increased as delta L. Am I right? You can see small change in length happens here. Am I right or not?
Yes, you're right.
So my delta L depends on that means my delta L is directly proportional to my original length. Am I right?
Yes, you're right.
And also my change in length depends on change in temperature. Am I right?
Yes, doctor.
So if I just join these two equations, I can write like this. Am I right? My delta L is directly related with L0 and delta T. Am I right?
Yes.
Yes.
But if I want to avoid this proportionality symbol, I have to introduce one constant, and that constant is alpha. So delta L is equal to the linear expansion coefficient alpha multiplied by L0 multiplied by delta T. My dear, don't get confused about this and this. This is the proportionality symbol. This is the constant. So don't get confused about these two. Understand?
Clear.
Okay, now, my dear, listen carefully. We have the same type of formula for the area expansion and the volume expansion. So, for example, you can see if you replace this L with A, you will get A like this. Am I right? Am I right?
Yes, doctor. Yes, you're right.
Likewise, if you replace this L0 with A0, you will get this. Am I right? So you can just see the equation of the linear expansion. It is delta L, which is equal to alpha L0 delta T. If you want to write the area expansion equation, you have to replace this L with A. So delta A, which is equal to replace this alpha with beta, and then replace this L0 with A0 and delta T as it is. And likewise, volume, you have to replace this letter V, and this beta becomes gamma, and then this becomes V0 delta T. But how we got this equation? My dear, how we got this equation? That's a very, very important thing. Yes, my dear, ask your question.
I think beta is equal to 2 alpha. And
2 times of alpha.
Yeah.
2 times of alpha. I will tell you how we got this 2 times of alpha. My dear, listen carefully. Could you please tell me what is the equation for delta L? Linear expansion. Linear expansion delta L, which is equal to alpha L0 delta T.
And temperature. Yes, you're right.
Am I right? Okay. How you can write this delta L? I can write like this. Am I right?
Yes, you're right.
Yes.
So which is equal to alpha L0 delta T. Am I right?
Yes, you're right.
Yes.
I am going to move this L naught to the right hand side. When you just move this minus L naught to the right hand side, what will happen?
It will
So
become
we
positive.
Positive. Therefore, L which is equal to alpha L naught delta T plus L naught. Am I right?
Yes.
yes.
If you
Yes.
take L naught as the common term, how you can write? You can write alpha delta T plus 1. Am I right?
Yes.
Yes.
Am I right? Now, I am going to use this equation because this is an equation for the linear expansion. Am I right?
Yes, you're right.
This is the explanation for, because when you just expand this equation, you will get like this. Now, what I am going to do, I am going to find the relation for area. What is the formula for area expansion, my dear? My area expansion formula is delta A, which is equal to beta A naught delta T. Am I right?
Doctor,
Yes.
how
Yes.
you replace the beta with alpha? I think beta is equal to 2 alpha, not 1
My dear,
alpha.
I will tell you, my dear, just give me some time. I will explain one by one. Clear? So beta,
Okay.
which is equal to 2 times of alpha. Am I right?
Yes, you're right.
Okay. Listen, I will tell you because I am a teacher. I will explain you. Don't worry.
Thank you, doctor.
Because it's my job. So 2 times of alpha. Now, my dear, I need the answer from your side. Okay. What is the formula for area? What is the formula for area?
L multiplied by L.
Very good. Area which is equal to L multiplied by L. Am I right? So
Yes.
I can use this L here. Am I right?
Yes, yes.
So how I can write A which is equal to L naught alpha delta T plus 1 and also one more L naught. Am I right? Multiplication of, my dear, don't get confused about this line.
All square.
Understand? So multiplication of L naught alpha delta T plus 1. Am I right? Clear?
What did you do, Doctor?
So I can take L naught together. So if you take together, what will get, my dear? A which is equal to L naught square, and this 2 becomes alpha delta T. Oh, this is
Doctor,
really irritating.
take off the USB and and input the USB of
My dear,
mouse.
no, my dear, I tried a lot. I think it will not work for me because, you know, in my laptop this is working very good, but right now I'm using the desktop because, you know, my eyes got irritation more. That's what I bought this desktop.
On Blackboard, Mr. Doctor. It's a problem from Blackboard, not from.
No, it's not a problem from the Blackboard, my dear. It's a problem from the desktop because this board, the writing board, is exactly good for the laptop, not for the desktop.
Same problem on Dynamics, Doctor. Another
because the doctor is also using the same thing. Okay, let's come for the point. No problem. Okay, now you can see, if you just see this term, it's like A plus B the whole square formula. Am I right?
Yes.
So what is the rule for A plus B? A square plus B square plus 2AB. So now could you please apply this rule for this part? If you apply for this part, what you will get, my dear? A L naught square. This becomes alpha square delta T square. This becomes 1 square. Am I right? 1 square is 1 square plus 2 into
Alpha delta T.
2 into alpha delta T. Am I right?
Yes.
Now, my dear, you can see here your delta T value. For example, if I have delta T value as 1, for example, my dear, if I have delta T value as 0.1 Celsius degree, what is delta T square value?
0.01.
That means which value is greater, my dear? Which value is smaller?
Delta T is greater.
So delta T is greater value when you compare with delta T square, because all the times the change in temperature happened to the material is not that much big, so only small level. So if you just see this value is very, very small. Am I right?
Yes.
So whenever you go for any physical calculation, physics or chemistry calculation, whenever a term gives a very, very smaller value, we can avoid the term from the equation. So according to this, if you just see this term has delta T square, so I can avoid this term. Am I right?
Yes.
Yes.
So what is left? What is left? L naught square 1 plus
2 the alpha delta T.
1 plus 2 alpha delta T. Am I right?
Yes.
Left hand side I have A. Okay. My dear, what is L naught square? L naught square is nothing but my A naught. Am I right?
Why, doctor, you delete them?
Huh?
Why you delete them?
Why?
Why you delete alpha square and delta T square?
Because, my dear, whenever you compare with the delta T with delta T square, all the times your delta T value will be smaller, very, very smaller. So whenever a term gives a very smaller value, you can remove the term from the equation. This is the rule. Clear?
Okay.
Yes.
Okay.
And
Now,
why you didn't remove the right delta T, doctor?
Because there's small effect for this.
Because of very smaller, because when you compare with delta T and delta T square, you can just see this example. If I have the temperature change is 0.1 degrees, 0.1 Celsius degree, if you're squaring this value, what you will get? 0.01, am I right?
Yes, yes.
So it's very smaller. So you can remove that term, no issue.
Okay,
Clear?
okay.
Okay,
Can
now,
you give us
what is A naught? What is A naught? My A naught is L naught multiplied by L naught, am I right?
Yes.
Yes, doctor.
So I can just replace this term with A naught, am I right?
Yes, doctor.
Yes, yes.
So left hand side I have A, and here 1 plus 2 alpha delta T. Clear? Understand?
Yes.
Yes.
Clear.
Could you please multiply this term inside? If you multiply this term inside, what you will get? A naught plus
Yes.
2 alpha A naught delta T. Am I right?
Yes.
Am I right or not? Don't get confused about this line. I'm extremely sorry for this.
No problem, mister. No problem.
So A naught.
Doctors, under the mouse,
Ah.
it's something not equilibrium. Under
No problem, my dear. No, I will manage. No problem. Okay. If you multiply inside, what will get? A naught plus 2 alpha A naught delta T. Am I right?
That's
Am I right
clear.
or not?
Yes.
If you move this A naught to the left hand side, what you will get? A minus A naught. Am I right? Which is equal to 2
Delta.
alpha A naught delta T. Am I right?
Yes, doctor.
What is this A minus A naught? My A minus A naught is nothing but delta A. Am I right?
Yes, doctor.
Yes.
And this
So
beta.
what is in the right hand side?
So
What is in the right hand side of the equation? 2
beta,
alpha
2 alpha A naught
A naught delta T. Am I right?
delta T.
and you have
Now
to change
I
the
can
beta
replace
to
this 2 alpha with beta. When you replace this beta, which is equal to 2 times of alpha, your equation becomes delta A, which is equal to beta A naught delta T. Am I right?
Yes.
Yes.
This will
We
be
got
the
the same equation here. Am I right?
Yes.
Clear? Likewise, if you want to try for the volume, same formula. What is the formula? V, which is equal to L multiplied by L multiplied by L. So here A plus B the whole square formula came, but when you are using the volume, you will get A plus B the whole cube. Am I right?
Yes, you're right. Doctors, how we
So
got
you will get the same method. Better you can take a practice, but better remember this equation, because the equation is very, very important for solving the problem. Understand?
Mister, the proof
Yes.
is important or not?
My dear, for your purpose, I just solve these things. In exam, you no need to write all these things.
Okay, doctors, here, how we get off the step number 4 for delta, for alpha square and temperature square? Steps number 4.
This one? This one?
Yes. How we got off?
This one, I'm using just this formula.
Okay, when we use, how we got off?
My dear, A square, this is your A term. This is your B term. Am I right?
Yes, you're right.
So alpha t delta t is your A term. So when you square that, what you'll get? Alpha square delta t square. Am I right?
Yeah, I understand that. But I mean, the 5 steps is gone. This two. This term.
He mean why you delete it?
Yeah.
Which
why
term?
delete?
Which term I deleted?
مثال
You mean this
هذاك
term?
مثال.
Yes,
Yes.
yes.
My dear, how many times I told you, my dear, your delta t square is very, very smaller value. You can remove the term from the equation. This is the rule in physics.
Okay, okay. Yeah,
This is
yeah,
the rule.
I got it.
Whenever the term is very, very small, you can say that term is the negligible value. What is the meaning for negligible value? It's very, very small.
Okay, okay.
Whenever the term is very, very small, you can remove the term from the list. No problem.
Yeah, I got it. Thank you, doctors.
Clear?
Clear.
Okay, is there any limits like?
For example, my dear, for example, you have 1000 real in your packet, for example. Okay?
Okay.
Out of this 1000 real, I just remove only quarter real, quarter halala from that 1000. So remaining what amount you have?
999.75.
So is it that much difference when you compare with this quarter halala?
No.
That is the same thing because you don't bother about the smaller value. Am I right?
Yes, yes, you're right.
That's the reason here.
Okay. Thank you, doctors.
Yes. Okay, my dear. So in such a way, you can use it for this volume, get the answer for the volume. But in exam, we need only these 3 equation and what is beta, what is gamma. Okay. But please keep this information, my dear. Each and every term, each and every material, it has its own alpha value. If you take a lead, alpha value is 29. If you take aluminium, it is 23. If you take a brass, it's 19. Likewise, each and material has its alpha value different. Okay.
Okay.
It's a constant, so don't worry about the constant. Constant will be given by us for solving the problem. So don't worry about these constants. Clear?
Doctor, here, clear. Here, what you mean about delta L, omega? Not omega. This here.
You mean this one?
No. Linear expansion. We have two rules.
Alpha.
Which 2 rules we have? We have only 1 rule.
Yeah.
We have only 1 rule.
Here in the red one, you got 2. Yeah. The first one.
My dear, this is the last equation, my dear. Both are same. This one and this one are same. This is the explanation for this equation. So don't worry about this explanation. Just to see the last equation.
Okay.
Clear?
Clear.
Okay. So now we come for studying the concept of specific heat capacity. If you want to find the specific heat capacity, my dear, like your alpha value, so your specific heat capacity value also have different value for different material. So here, if you want to find the specific heat capacity formula, you have to extract this formula from the heat absorbed by the material. So we already studied Q is the heat, am I right? So if any object absorb the heat, so it depends on the mass of the object, it depends on the specific heat capacity value of the object, it depends on the change in temperature of the object. So the heat absorbed by the solid and the liquid medium depends on the mass, depends on the specific heat capacity C, and it's depend on change in temperature. Now by using this formula, you can easily find the specific heat capacity. Could you please rearrange this in terms of specific heat capacity? So C, which is equal to Q divided by mass multiplied by delta T. Am I right?
Yes.
So if you want to give the definition, suppose we are asking define specific heat capacity. So you can just write this equation, explain each and every term. So C is the specific heat capacity. What is Q? Heat absorbed, am I right? And what is M?
Mass.
Mass of the object. What is this delta T?
Change in temperature.
That means this has the final temperature and the initial temperature. Am I right? So the definition for this, you can extract from the formula from the heat absorbed, and when you just substitute all the values, you can get the value of the specific heat capacity. My dear, specific heat capacity of the material is a constant. So this C value will be given in your exam. So don't worry. Understand?
Yes, Doctor. Yes, Doctor.
Yes.
Okay. Now we come for studying the concept of work done by the gas. My dear, you can see the picture. You can see this picture. I have a container, and inside the container I have only one piston. Forget about this piston. You consider only this piston. So I have a container. I have one piston. Now inside the container I have some space. In this space, what I have?
Gas.
Gas.
Gas. Okay. Now you are going to heat this container. What will happen, my dear? When you heat this container, what will happen? The gas molecules get expanded. Am I right?
Yes, you're right.
Am I right or not? Whenever you heat, the gas gets expanded. So whenever the gas will get expanded, so initially this is my volume. That means this is my V1 value. Am I right?
Yes, you're right.
Yes.
So when you heat this container, this gas molecule get expanded. It will push this piston to some extent. Am I right?
Yes, you're right.
Yes,
So when it pushes to some extent, what will happen? You will get the new volume from here to here. Am I right?
Yes.
Yes,
So
you're
you will get change in volume here. Am I right?
Yes. Yes.
So if you get change in volume, what should be the pressure? Your pressure will not change. Your pressure remains the same. Am I right or not?
Yes, Doctor.
Yes, you're right.
So if you want to find the work done by the gas, you have to use the formula work done, which is equal to P delta V. My dear, in general, how we got this formula? We got the formula from our basic formula we already studied in physics 1. What is the formula for work done? Force multiplied by distance. Am I right?
Yes, you're right.
Yes.
So what is my distance, my dear? My distance is final minus initial. Am I right?
Yes.
Yes, you're right.
What is your force? You already studied this formula from chapter number 14. Force, pressure, which is equal to force over area. You studied, am I right?
Yes.
Yes.
Therefore, F, which is equal to P multiplied by A. So in this place, if you put P multiplied by A multiplied by your final position minus the initial position, you will get this term. Am I right?
Yes, you're right.
When you multiply this A term inside, what you will get? You will get P multiplied by A multiplied by XF minus A multiplied by XI. Am I right?
Yes,
Yes.
you're right.
What is this, my dear? This is your volume. Am I right? Area multiplied by some distance gives you a volume. Am I right? So
yes.
I can write P multiplied by V final minus V initial. What is this V final minus V initial? V final minus V initial is
Delta
nothing
V.
but my delta V. So my work done formula is this. Where we got this? We got from the work done formula. Understand?
Understand.
Yes.
Doctor,
Oh, yes.
this here V, it's mean volume, am I right?
Yes, V stands for volume, P stands for pressure.
Okay.
But don't use the speed. Here speed will not work here, my dear. We are talking about the pressure, volume.
Yes. Yes.
Okay. Now, if you want to study the work done, my dear, listen carefully. Sometimes we will explain the concept in terms of pressure volume variation by this type of graph. If you just see this graph picture, I have 3 different color line. Am I right?
Yes, you're right.
Yes.
So one is green color. My area A has green color. My area of that means the line yellow have B, and the line this purple color has C. Am I right? That means I have A, B, and C. Now what we are going to do? We are going to calculate what is the work done by path A. What is the path? The path A is this. Am I right? Am I right or not?
Yes.
You're
Yes.
right.
So if you want to calculate the work done by path A, path B and path C, what you have to do, you have to consider, if you have any lines, you have to consider the region as your area. For example, you can see the next slide. I am just dividing each and every picture according to the line. So the next slide, you can see I only have the path A. Am I right?
Yes, you're right.
Yeah.
So in this path A, these are all shaded portion is my area cover under this A. So under this line, this many area is coming. Am I right?
Okay,
Yes,
you are
doctor.
right.
So under this line, this many areas came. Am I right?
Yes, you're right.
So we have to consider, whenever you have this type of question, you have to consider, if you have any line, please consider the area under the line. For example, here the green color line, under this green color, this many shaded region is my area. Understand?
Yes, doctor.
Understand?
Yes, doctor.
Okay. Now see the picture, my dear. See the picture. This is 0. This is P naught. That means it's 1 P naught. Am I right? So what is this value? What is this value? What is this value?
1, 2, 3.
My dear,
P
this is
naught
1 P
over,
naught. Am I right? If this is 1 P naught means, what is this value?
Half.
P naught over 4.
0.3.
Quarter.
This is
Yes.
quarter P naught. Am I right?
Yes.
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 This is half P
P
naught.
naught
Am I
half
right?
P.
This
3
is
over 2.
3 over 4.
3 over 4.
4, yeah.
Clear? Clear?
Clear.
Yes.
Okay, likewise, you can see the x-axis. I have volume. That means V naught means it's 1 V naught. Am I right?
Yes.
Yes.
What is this?
2 V naught.
2,
What is this?
3.
3 V naught.
This is 4 V naught. Understand? Understand, my dear?
Yes,
Yes.
doctor.
Now you have to use this graph for finding the work done by path A. So we know the formula. What is the formula, my dear? Work done. Pressure multiplied by change in volume. Am I right?
Yes, you're
Am I
right.
right?
Yes, doctor.
Okay, you can see the
Yes,
line.
doctor.
How many areas? For example, this is the area covered region. Am I right? Y-axis. Am I right or not?
Yes,
Yes.
doctor.
Yes, yes.
So what is your P value? My P value is 1 P naught. Am I right?
Yes.
What is your V naught? It is from here to here. Am I right?
Yeah, the difference
So,
between them.
Difference between
Okay.
these two. That means 4 V naught minus 1 V naught. Am I right?
Yes, yeah.
So what will
Yes.
be your answer?
3.
P naught multiplied by 3 V naught. Am I right?
Yes, you're right.
Yes.
So the
Yes.
work done by path A is given by 3 multiplied by P naught multiplied by V naught. Am I right?
Yes, you're
Yes.
right.
Yes.
So what you have to do, if you have this type of question, you have to see the picture. Whenever the picture have some line, consider the area under that line. So whatever the line you have under that line, whatever the portions you have, that is your area. Clear?
Clear,
Clear.
doctor.
Yep.
Okay. Likewise, let's we come for B. What is my B, my dear? I think, my dear, if you just see this, you will not get. Better I can just draw some picture. You can just see. So this is my graph. My dear, listen carefully. This is my graph. After that, I will delete. This is our B path. Am I right?
Yes.
Yes, you are right.
Now you have to consider whatever the area under this line is your area. Am I right? Now you can see this is the region of our area. Am I right? All this area is your area. Am I right?
Yes. Yes.
Now,
Yes, you're right.
but if you
Try-
just see the
try-
structure is not exactly seems good. Am I right? Is there any specific formula you have for this diagram?
Yes, yes, doctor.
Yes.
What formula you have, my
triangle.
dear?
Triangle.
So this is your area, my dear. Listen carefully. This is your area.
Minus multiply
your-
base multiply.
Listen. I can divide this picture into two different shapes. So if I put one line, this is my rectangular area. Am I right?
And triangle. Yes.
And this is my triangular area. Am I right?
Yes, you're
Yes.
right.
Doctor.
So that's what I gave the picture like this. So this type of area has two different shapes. One is triangle shape, second one is rectangular shape. So I have to write here area of the triangle. You can see I just only make the name for this triangle. A, B, C is my triangle. We know the formula for area of the triangle. What is the formula for area of the triangle, my dear?
Half multiplied by length
Okay.
multiplied by height.
Very good. Length multiplied by height. Am I right?
Yes.
What is the formula for rectangle?
Length
Length multiplied by width. Am I right?
Yes.
Yes.
Okay. Now listen carefully. This is our formula. Okay. What is our length, my dear? Here. What is our length? Our length is this. Am I right? Our length is this. Am I right?
Yes.
Yes.
This is our height. Am I right?
Yes.
Yes.
So what is your length, my dear? Here. 4V0 minus V0. Am I right?
Yes. Yeah.
So I can write here. I can just write for the triangle. I can just write it here. I can write it here better. Okay, you can just see. Half for triangle. What is the formula? Half length multiplied by height. Am I right? So I can just write half outside. What is my length? My length is 4V0 minus V0. Am I right?
Yes.
What is my height? My height start from here to here. Am I right?
Yeah,
Yes.
3/4.
So what should be the value, my dear?
B minus B over
My dear,
4.
listen. Each box is quarter. Quarter, half,
For B.
3/4, 1. So if you have the height from here to here, what should be the value?
B minus B naught minus B over 4.
3P0/4. Am I right?
Yes.
It's okay. Now if you simplify, what you will get? Half. This becomes 3V0.
V0.
This becomes 3P0/4. Am I right?
Yes.
When you simplify, what you will get, my dear? You will get 9P0V0 divided by 8. Am I right?
Yes.
Yes.
You got for the triangle here. Am I right?
Yes.
Okay, doctor.
Okay.
I don't understand here. 3B0/4. How we got it?
Okay. You want to know these things. Okay. Okay. I will tell you one more time. Listen carefully.
Okay.
See the picture. Okay. My dear, see the picture. See the picture. Okay.
Okay.
This is your length. This is your length. Am I right?
Yes, you're right.
What is your height? Your height is this. Am I right?
Yes, you're right.
So each box is quarter. Am I right? So that means quarter. This one is half. This one is 3P0/4. Am I right?
Yes, you're right.
So out of this 1P0, quarter is missing. Am I right?
Yes,
What
yes.
is remaining? What is remaining?
Remaining 3B0/4. Yeah. Yes,
That's
you're
what we
right.
wrote like this. Okay.
Okay. I got it.
Clear? Okay. Let's come for the rectangle. What is the formula of rectangle? Length multiplied by width. My dear, this is my length. Am I right?
Yes, you're right.
What is your width? What's your width? This is your width. Am I right?
B over 4.
So we have to write for the rectangle. This is my rectangle shape. Length multiplied by width. So my length is 4V0 minus 1V0. My width is P0/4. Am I right? So
Yes.
what is remaining, my dear? 3P0V0/4. Okay, now we got this. Am I right?
Yes, you are.
Yes, you're right.
Okay, now you know how to simplify. Take the least common multiple, LCM. When you just take LCM, you have to simplify these two terms. Finally, when you simplify, you will get this term. Am I right?
Yes, doctor.
So work done by the path B is 15P0V0/8. Clear?
Clear.
Okay. Likewise, work done by path C. So you have only one line here. Is there any area under this line? Under this line? Is there any area under this line? No area. Am I right?
Yes.
Yes.
But you have line here. So in this line, you have some area. Am I right?
Yes.
Yes.
So we have to use another against the same formula, work done, which is equal to P delta V. My dear, here you have P only here to here. Am I right? Am I
Yes,
right or
you're
not?
right.
So what is
Yeah.
my pressure? My pressure is P naught over 4 only. Am I right? Quarter region only we have. Am I right?
Yes.
Yes, you're right.
So what is your V naught? Your V naught again between 4 V naught to 1 V naught. So I have to write 4 V naught minus 1 V naught. Finally, my answer is 3 V naught P naught over 4. Am I right?
Yes, you're right.
Sure.
Okay, my dear, listen carefully. I'm going to take the final answer. We have one problem. You can just have a look here. The problem number 17, I think so. You can see that for this problem, the picture is exactly the same. Am I right?
Yes, you're right.
You can see the division, what they give for the x-axis, exactly the same. 1 V naught, 2 V naught, 3 V naught, and 4 V naught. What is this? This is quarter P naught. This is a half P naught.
Half P naught.
This is
34.
3 P naught over 4. This is 1 P naught. Am I right?
Yes, you're right.
So what you are going to find, my dear? What you are going to find? You are going to find work done by path A, path B, and path C. Am I right?
Yes, you're right.
So again, we have to explain the same thing. So better, I can take the final answer. So what answer we got for work done by path A? What answer we got for work done by path A?
3 P naught V naught.
We got this, am I right? So I can take 3 P naught V naught. 3 P naught V naught. What is the formula for B? I think 15 P naught V naught over 8. Am I right?
Yes.
Yes.
Sure.
Yes.
And work done by path C?
3
3
P naught.
P naught V naught over 4. Am I right? Okay.
Yes,
Now, my dear, in this question, you can see V naught value is given. What is that value?
1 meter
1
cube.
meter cube.
Okay. What is the value for P naught?
60 Pascal.
4 Pascal.
Substitute the value here. Get the answer. 3 multiplied by 60 multiplied by 1. Am I right? What is the answer?
180.
18. Okay. Here, 15. My pressure is 60 Pascal. My volume is 1 divided by 8. I think 112.5 something you will get. I think so. Better I can use my calculator. So what you will get? 15
112.5.
Answer
Okay.
correct.
multiplied by 60 divided by 8. Am I right? I think 112.5. Am I right?
Yes.
What is the answer here? 3 multiplied by 60 multiplied by 1 divided by 4. I think you get 45. Am I right?
45, yes.
Yep.
What answer we got here, my dear?
Doctor,
The same.
how can I know include the, for example, for B include the triangle and the rectangle? How can I know that?
How you have to know? You can just see, my dear. You can see only this line. Okay. You can see your area is here. Am I right? Your line is coming like this. Am I right?
Yes.
You have to consider how many areas it will be coming here. This is your area under this curve. Am I right? Am I right or not?
Yes, yes,
Yes.
you are, Doctor.
So I can just make some picture from here to here. It's a triangle. Here to here, it's a rectangle.
Okay, but the question is, like for example, let's see in the figure.
Do you have any formula for this shape, my dear? Okay, my dear, listen. Do you have any formula for this shape? If you have any formula, please let me know. Better we can use that. Do you have any formula for this shape? Do you have any formula
No,
for
there's
this
no
specified
formula.
shape? So, for getting the clear answer, we have the specified formula for the triangle. We have the specified formula for the rectangle. Am I right?
Yes, Doctor, yes.
That's what we just choose. Even if you divide, your answer will not change.
Okay, doctor. For C, how can you know?
C.
Can you do it for C?
Because I'm drawing C only. This is your C. Am I right? Am I right or not?
Yes.
Yes.
Okay, what is the area? Your area is only between here. Am I right? Am I right or not?
Yes, you're right. Why we consider the under the line?
This is the rule. If you want to find the work done, you have to consider the area under the line.
Okay, but we should find the area of what I mean. Why we don't consider like a triangle of C? You know.
Here is there any triangle here, my dear? Is there any triangle for C?
C and B, it's come to a triangle.
Is there any triangle
can
for C?
When we consider C and B,
Is there any triangle for C? Just tell me.
no.
Then
But
why you
when
want
we
to add
consider
triangle
under
here?
the line? It's come same.
Under the line. For example, my dear, here there is no line. How you can consider this area?
We can't. But
No,
under
it
the
is.
line,
So
it's
only
come
you will
same.
consider. For example, is there any area under this line? Is there any area under this line? No area. Am I right?
No area. Yes, you're right.
But here in this line, you have some area. Am I right?
Mr. Doctor,
you're
can
right.
I translate base for this?
Yes, this is the area of the rectangle. This is exactly area of the rectangle. Only you will get the answer. This is the shape
Okay.
of the rectangle. Am I right? What is the formula for rectangle, my dear? Length multiplied by width. Am I right?
Yes, you're right.
Yes, doctor.
Very
What is the
basic.
length? My length is 4V0 minus 1V0. Am I right? What is
Yes.
my width? My width is only P0 over 4. Am I right?
Over 4, yes.
Am I right or not?
Yes, doctor.
You will
Yes,
get the
you're
same.
Doctor, sorry, doctor.
Yes.
Can you repeat for C why you include the down one?
My dear,
My internet.
whenever, for example, if you have any picture with line, okay? If you have any picture with line, for example, if you have this line only, forget about this. Better I can just delete all these things. Erase all these things. Okay, I can just draw the line. What line is given for C? What line is given for C? Your line is like this. Am I right?
Yes.
Okay, now I can change the color. I can change the color for drawing the area. Better I can change the color. Where is the color? Okay, I can just choose the red color. Oh, it's already red. Huh? Okay, now you can see. Is there any area under this line? Is there any area under this line? Is there any area under this line, my dear?
Yes, you're
No area under this line because it's exactly a straight line. Am I right?
yes, you're right.
Yes.
Yes.
But when you just see this line, you have some area. Am I right?
Yes, you're right.
I'm extremely sorry, my dear, because this pen makes some trouble for me. This is your line. There is no line under this perpendicular line. Only you have the area under this line. Am I right? Am I right or not?
Yes, you're right.
This seems like the area of the rectangle. Am I right?
Yes, you're right.
That's what we are using this rule. Understand?
Same calculus too.
Yes.
Yeah, we use
Doctor.
calculus too, like this.
Integration.
What?
You can use integration.
I couldn't hear, my dear. Just talk it a little bit loudly.
You can use calculus for that.
You are using in the calculus, finding the area under the line. You already studied in calculus too.
Yes.
Yes, yes.
No, doctor.
Yes,
I
doctor.
guess he means user integration.
Yes,
Integration.
my dear. If you are using the integration or the same formula, the concept, the answer will be the same.
Yes, you're right, doctor.
Am I right? The answer gives the same, my dear. If you are using the integration or the basic method, your answer remains the same.
Yeah, because we don't have rules for this line, and we find.
This is
for
very easier
calculus
question,
too.
my dear. Don't worry. We will ask the same type of question in your exam, so don't worry.
Yeah, thank you,
Clear?
doctors. Clear.
Clear? Okay. Let's come for the first law, because first law is only remaining out of this 4. Am I right? My dear, first law of thermodynamics, you have to use this formula. What is this formula, my dear? What is this formula? This is our formula. What is this? Could you please rearrange this equation in terms of heat? Q, which is equal to change in internal energy plus W. Am I right?
Yes.
Yes, you're right.
Okay. Now I need the answer from your side. My dear, I need the answer. I have a container. Inside the container, I have a piston. Okay. Clear?
Yes.
Inside the container, I have some space. So here I have some gas molecules. Understand?
Okay.
I am going to heat this container. What will happen, my dear?
We'll push.
The molecules move faster.
When you heat the container, the gases inside the container get expanded. It will push the piston in the upward direction. Am I right?
Yes.
Yes.
So that means, listen carefully, when it pushes this piston from this position to this position, some work is done. Am I right?
Yes.
Yes, you're
Yes.
right.
So the amount of heat energy I applied to the system, which is equal to some amount of work is done to move the piston from one region to another region. That means one point to another point. At the same time, what is happening here? Here the gas molecules get expanded. Am I right?
Yes.
Yes, doctor.
That is nothing but some energy. Because of the internal energy, the gases get expanded. Am I right?
Yes.
Yes, you are right.
So the amount of heat supplied to the container makes the piston moves little bit in the upward direction according to this picture. So what you understand from this picture, the amount of heat supplied to this object, which is equal to the amount of work done plus the change in internal energy. Understand?
The Q, doctor, is the amount of
Shall I tell you one story, my dear? Shall I tell you one small, easiest example?
Yes.
Okay. Now I think you will get some idea. I have. What is this? This is fire. Okay.
Yes.
What is this?
Rice.
What is this?
Same like rice inside.
I'm not a good artist, but anyhow, I will try to draw some picture. So this is my fire. Okay. I have some wood. I just make fire. Okay.
Okay.
Top of the fire, I take one needle. That means the lengthiest rod, and I attach some chicken.
Chicken or rice?
Chicken is a good example. Okay.
Okay.
Now I am just rolling this chicken. What will happen, my dear? Initially, the chicken is raw, okay?
Yes.
So you want to cook this chicken, am I right?
Yes.
So if you want to cook the chicken, what is needed?
Fire.
Higher.
Fire. That means heat is needed, am I right?
Yes.
Okay.
Yes.
Okay, you pass the heat to this chicken. When you pass heat to this chicken, inside the chicken, some internal energy takes place, am I right? Some reaction takes place, am I right?
Yes.
Yes, you are right.
When the reaction is over, that means the work is done. You are ready to eat this, am I right?
Yes.
Yes.
So amount of heat energy supplied to the chicken, which is equal to some amount of internal energies happen inside the chicken, raw chicken, and after some time, work is done. Clear?
Yes, clear, doctor.
Okay.
Clear, my dear?
Doctor, is there any thermal here?
No. Here there is no thermal. The heat is your thermal energy, my dear.
Heat. Okay.
Your heat is the thermal energy. Why you just go for another thermal energy?
Because I think two system
No.
reaction.
Only one energy, which is nothing but heat energy. Understand? So, my dear,
Okay.
your first law of thermodynamics, you have to memorize this equation. Either this or this. Both are same. Both are same. Okay? Understand?
Okay.
Yes.
Understand.
Yes.
In next chapter, in chapter number 19, we are going to solve some question. If you want to solve the question, you need this equation. So it's very, very important. So please memorize this. Okay?
Okay. How about D?
Okay.
D here. D.
No. This is the same, my dear. Here you have internal energy. This is a small fraction. And here you have small amount of heat, small amount of work done. So, but
Okay,
we have to
what
consider
mean D?
only this. Both are same.
Same. Okay.
Both are same.
Doctor,
Okay. Let's
what's
take a look at that.
what's our work done in the system in that situation?
When the internal energy is over, work is done.
Oh, okay. You mean when the whole process finished?
Yes.
Okay.
Okay, now we have three types of heat transfer. The three types are conduction, convection, and radiation. My dear, from this slide, some theory question will be there. If you want to transfer the heat from one point to another point, through these three methods, you can transfer the heat. So, through conduction, my dear, conduction always takes place in solid material. Convection always takes place in
Fluid.
what is this?
Fluid.
What is fluid?
Fluid and gas.
Liquid as well as
Fluid,
gas
liquid
forms the
and
fluid.
gas.
Am I right? So convection, liquid and fluid in gases, you can transfer the heat by convection. And then radiation, no need, because if you just stand outside during the summer time, you feel more heat energy. Am I right?
Yes, you're
Am I
right.
or
Yes.
not?
Yes.
You are standing outside. You can just take an example, my dear. During the summer time, when you are just standing outside, what will happen? Without any medium, you will get the heat energy. You will feel the heat energy. Am I right?
Yes.
Yes, doctor.
That means the heat is transferred to vacuum. Am I right or not?
Yes.
Yes, you're right.
So here the medium is in terms of solid. Here the medium is fluid, but here you don't need any medium, vacuum medium. That means the good example, you can get the heat energy from the sun. So here, if you just see these things, what will exactly happen when you just take one rod? For example, see this picture. This person is heating water by using the vessel. This vessel is made up of solid material. Am I right?
Yes.
So when you place this vessel under the fire, what will happen? The fire will be transmitted through the small atom, because the solid medium, all the atoms are closely packed. Am I right?
Yes, doctor.
Yes.
In solid, all the atoms are tightly packed. So if you disturb one atom, what will happen? It will transfer the energy to the neighboring. The neighbor will transfer the energy to the another neighboring. So immediately you will get the heat energy. Understand?
Yes.
Yes.
Okay. When you see inside, you have water. Am I right?
Yes.
What do you understand from this picture? I think you can observe these things in your home. When you are about to cook something, you take a vessel, you just put some vegetables inside and heat that vegetables with water. What will happen, my dear, after some time?
It will up and down.
Up and down. You can see the bubbles. Oh, it's coming up and then going down, coming up, going down. Am I right?
Yes, they called the cold one.
So you can just see here, once the objects gets more heat, it will be coming up. So the molecules should be moving up and down. Clear?
Yes.
And then when you come for the radiation, you don't need anything because it's a vacuum. The the heat is transferred through vacuum. The good example is the sun. Okay?
Vacuum like space, sir?
Yes, space. If you just stand outside, is there any medium between you and the sun?
Air. Okay, I get it.
But it's empty, am I right? Air you have, my dear, but it's empty, am I right or not?
Yes.
So that we can say it's a vacuum. Vacuum means it's not a meaning of completely or remove the air. You have some air medium, but there is no medium. There is no material between you and sun, am I right?
Yes.
So through these three methods, you can transfer the heat. Clear?
Yes, clear.
Now, finally, we will conclude the slides, this chapter with this heat transfer. My dear, if you want to find what is the conduction rate, if you want to find only the conduction rate, we have the formula power which is equal to Q over T. So Q stands for the heat energy, T stands for the time taken. So which is equal to this Q over T is also equal to this parameter. So if you want to calculate the conduction rate depends on, it is directly related with the area of the material. For example, you can see this picture. My dear, I have the hot region and the cold region. In between this hot region and the cold region, I take one material. For example, you can take an example of the copper. I take a carbon material, the copper material, this much size. Okay?
Okay.
I attached this one end of that means I attached both reservoir with this copper material. So that means the copper material is exactly attached between these two reservoirs. Okay? Understand?
Yes.
And this material has area. Am I right?
Yes.
And this material has some length. Am I right?
Yes.
So your conduction rate depends on area of the material. Your conduction rate depends on change in temperature, and also your conduction rate is inverse relation with the length. So when the length will be increased, what should be your conduction rate?
Low.
When the length will be shorter, what should be your conduction rate?
Decrease.
High. So when the length is more, conduction rate is low. When the length is small, your conduction rate is high. Keep this information. Understand?
Yes, doctor.
Now I want to make these three equations as one equation. So how I can write? I can write my conduction rate is directly related with the area of the material, change in temperature, and then it is inverse relation with the length. So now if I want to avoid this proportionality symbol, I have to introduce one constant, and that constant is thermal conductivity constant. So if you want to remove this proportionality symbol, you have to introduce one constant K, and this K is called as thermal conductivity. So P, which is equal to K multiplied by area multiplied by delta T divided by length. Clear?
Yes.
Clear, my dear? And likewise, your K is also have different value for different material. For example, if you take a copper, what should be the value of K?
401.
If you take silver, 428. If you take iron material, 67. So this K value will be given. Clear?
Yes.
Clear.
Understand?
Yes.
Yes, doctor.
Okay.
Yes.
Now these cases, my dear, listen carefully. These cases we are going to use in chapter number 19. These cases we are going to use in chapter number 19. My dear, if you want to use these cases, you have to memorize the first law of thermodynamics. What is your first law of thermodynamics? Q, which is equal to change in internal energy plus work done. Am I right? Okay. Now, my dear, listen carefully. What is the meaning for isothermal? What is the meaning for
Constant
isothermal?
Temperature.
Constant temperature. So if we give one temperature means throughout that reaction your temperature is constant. What is the meaning for adiabatic?
No heat
Not
flow.
heat.
No heat.
Flow.
Okay. Can you please substitute heat is equal to 0? What you will get? If you put 0 Q, what will happen? Your change in internal energy which is equal to negative of work done. Am I right?
Yes.
Yes,
See, we
sir.
got this. Understand?
Yes.
Clear?
Yes.
Okay. If you have a constant volume, for example, you are heating some object. If there is no change in volume, work done is 0. Am I right? If there is constant volume, indirectly it says work done is 0. Am I right?
Yes.
So if you put work done is equal to 0 in the first law of thermodynamics, what you will get? Q which is equal to
Delta E.
change in internal energy. So likewise, my dear, we are going to use these special cases in chapter number 19. Understand?
Yes,
Yes.
Doctor.
So please memorize the first law of thermodynamics. It's very, very important. And inshallah, my dear, tomorrow you are going to write your quiz 1. And please, today after this session, I'm going to put one announcement. I'm going to enter one announcement in your blackboard regarding your quiz 1. Please kindly read that announcement. This is some instruction about your quiz 1. My dear, if you have any issue, please, first of all, read these things. I will give all the information perfectly, clearly in that message. So please have a look. Understand?
And
Yes,
doctor.
doctor.
Thank you, doctor.
And we have 5 problems. We already finished this. Am I right?
Yeah.
Yes.
Yes.
So the remaining 4 problems, inshallah, we will discuss in week number
4.
4. That's it. So my dear, after this session, after this class, you have 1 period. Am I right? As your discussion class. So I
Yes.
open one session already. Inshallah, I will be there exactly by 2 o'clock. Clear?
Doctor,
Okay.
can you make it
Yes.
in the evening?
You mean after 3 o'clock? After 6 o'clock?
Yes.
No, my dear, I'm sorry, my dear, because last time I faced a lot of issues regarding this after 6 o'clock, because I have some personal work also. Please try to understand that.
Doctor, will it be recorded?
You mean this chapter or what you need? You mean the discussion class?
Yeah, the discussion class. If you're gonna review something.
What you need from the discussion class, my dear? Huh? What information? Because you are going to ask me a question, I am going to explain why I want to record these things. Huh?
True, but I was just going to ask, like, if someone asks a
No
good question,
problem.
because
Our
unfortunately I
WhatsApp group is
will.
listen. Our WhatsApp group is open for all the time. If you have any questions regarding the chapters, you can raise the question. Sometimes I may delay, but I will answer your questions. Understand?
Thank you, doctor. Because
Thank you, doctor.
unfortunately I don't say this.